Hey everyone, Mr. Hauk here. In this video, we're going to go over the 3.1 to 3.3 quiz review. Okay, so number one, consider the function g of x equals negative 2 times x minus 3 cubed plus 7. What is the parent function for g? List all transformations that resulted in g from its parent function. So we can see because we have some kind of cubic function, the parent function was y equals x cubed. All right. Now the transformations, let's go through the transformations one by one. First thing I'm looking at, I'm looking inside for any kind of horizontal shifts or any horizontal stretches or shrinks, things like that. So I notice inside of the cubic function, inside of the part that's being cubed, I see this minus 3 here. If it's happening, if we have addition or subtraction happening inside of the function, we know that it's going to be a horizontal shift. So this minus 3 is going to shift our graph to the right 3. Then I'm noticing this 2 that's being multiplied outside of the cubic part. So if something is being multiplied on the outside of the function, we know that's a vertical stretch. So we have a vertical stretch by a factor of 2. Next, I see this negative that's being multiplied outside of the cubic function. If you have a negative on the outside of the function, it is reflecting over the x-axis. And then finally, this plus 7, when you have something added or subtracted outside of the function, so this plus 7 is being added outside of the cubic part. Something added or subtracted outside of the function is resulting in a vertical shift. So plus 7 on the outside is representing a vertical shift up 7. All right, number 2. What does it mean for a function to have increasing average rates of change over its entire domain? So keyword there being key phrase, increasing average rates of change. So there's a difference between average rates of change being positive and negative and average rates of change being increasing or decreasing. In fact, on that Unit 3 main ideas, which is a document that, again, I highly recommend you look through, I'll lay out the difference right here. Average rates of change positive means the function is increasing. Average rates of change negative means the function is decreasing. But if I say, instead of positive or negative, if I say average rates of change increasing, I'm actually talking about concavity, specifically concave up. If I say average rates of change decreasing, I'm talking about the function being concave down. So if I say increasing average rates of change over its entire domain, that means the function is concave up on its entire domain. And that leads us into number 3. So number 3 says, which of the following parent functions has increasing average rates of change? So that means which function is always concave up on its entire domain. Well, linear functions, y equals x, linear functions don't have concavity. Okay, straight lines don't have concavity. So that would not apply to A. Y equals x squared, so the parent function, the parent quadratic function, well, the parent quadratic function is always concave up. So that's going to end up being our answer. It's always concave up for the parent quadratic. But let's look at the others as well. The parent function for cubic, y equals x cubed, is only concave up from 0 to infinity. It's concave down from negative infinity to 0. So this is not always concave up. And then y equals square root of x is actually always concave down. Okay, so the only function that is increasing, has increasing average rates of change, aka concave up on its entire domain, from these 4 is y equals x squared. All right, number 4. The graph of a quadratic function with vertex at a comma b is reflected across the y-axis to obtain the graph of g. Which of the following statements is guaranteed to be false and why? And let's also explain why the other statements are true. So the key here is reflected across the y-axis. And when we reflect something across the y-axis, what it actually does is it just changes the x values. You can see it real easily. Let's consider like something like this. Let's say I have a quadratic over in quadrant 1. Well, if I reflect these points over to across the y-axis, so here's the y-axis right here, notice the x values are different. This would be like, let's say this was 5 on the x-axis right here. Well, the x values would have the opposite sign, but the y values are still the same. So when you reflect something across the y-axis, the x value is changing sign, the y value remains the same. Okay? So let's look at these statements. The vertex, the new vertex of G, is negative a comma b. This is going to be true. If f's vertex was a comma b, and reflecting across the y-axis only changes the sign of the x value, then the new vertex, if we change the sign of the x value a to negative a, the new vertex will be negative a comma b. So that's true. The axis of symmetry of G is x equals negative a. This is also true. An axis of symmetry is an invisible line that basically cuts your quadratics in half. Okay, so let's say, for example, that this quadratic, let's say its vertex was positive 5, positive 1. Then the axis of symmetry, this invisible line that runs through the middle of the quadratic, would be x equals 5. So the axis of symmetry is x equals whatever the x value of your quadratic's vertex is. Okay? So since the new vertex of G is negative a comma b, we saw that from part A, then the axis of symmetry for G is going to be x equals negative a. All right, statement C. The domain of f is x is greater than or equal to 0, and the domain of G, so G is after you reflect f over the y-axis, the domain of G is x is less than or equal to 0. This is false. Every single quadratic, no matter what you do to it, will always have a domain of all real numbers. The range can change. We've seen that in some homework problems, but the domain of every quadratic is all real numbers. And then part D, the y-intercept of f is the same as the y-intercept of G. This is going to be true. When you reflect across the y-axis, you only change the sign of the x values. But a y-intercept, so, like right here, a y-intercept has an x value of 0. And 0, you can't make 0 positive or negative, so, the x value of 0 doesn't change. So the y-intercept, even when you reflect over the y-axis, the y-intercept is going to be the same. But if you reflect over the x-axis, the y-intercept could be different. All right, page 2. Maria's parents are planning a party for her. One catering firm charges $24.50 per person for dinners with at least 10 people. If the party has more than 20 people, the price per person is reduced to $20.50, and for parties with 30 people or more, the price per person drops to $17.50. The banquet hall they reserved can have a seat maximum of 75 guests. All right, so me personally, I prefer to write the piecewise function first, so I actually did part E first. So what I'm noticing here, one catering firm charges $24.50 per person for dinners with at least 10 people. So if you have greater than or equal to 10 people, they're going to charge $24.50 per guest. But once you get more than 20 people, the price is going to change. So this initial price is running from 10 to 20 people. Okay? Notice I'm putting or equal to signs on both the 10 and the 20. So with at least 10 people, that means greater than or equal to 10. And the next price change doesn't happen until you have more than 20 people. So when you have 20 people exactly, we're still using the original price, $24.50 per guest. All right, now, from 20 people to 30 people, the price is $20.50 per guest. Again, so let's read very carefully into the problem because we want to make sure we get these inequalities correctly. So it says for parties with 30 people or more. So with 30 people or more, that's greater than or equal to 30. So the last section is going to have the or equal to part. So this middle section doesn't get the or equal to part. We cannot have an or equal to sign on both of these 30s. And right here it's specifically saying for parties with 30 people or more, the price drops to $17.50 per guest. So that part gets the or equal to sign. So from 10 to 20, price is $24.50 per guest. From 20 to 30, $20.50 per guest. And from 30 to 75, $17.50 per guest. And please make sure that you pay careful attention to the inequalities there. Okay? So, what's the dinner cost for 16 people? Well, 16 people, 16 would fall within this interval right here. So we're going to do $24.50 times 16. That gives us $392. Dinner cost for 22 people. 22 people falls within this interval. So we're going to use this equation. $20.50 times 22, that's $451. For 60 people, well, 60 people falls in this interval, so $17.50 times 60, that's going to give us $1,050. Now, the next part, we want to make sure that we understand, in context, certain values that in the domain are not possible. So if we read into the context again, the first catering firm charges $24.50 per person, but you have to have at least 10 people to be able to use this catering service. So we can't have any values of G. We can't have less than 10 guests. And it also tells us the banquet hall can seat a maximum of 75 guests. So I also can't go higher than 75 for my number of guests. But another thing that we need to pay attention to, we can't have non-integer values. So integer values are whole numbers like 1, 2, 3, 4, so on and so forth. You can't have fractions of people. So the values of G have to be integer values. They can't be less than 10 because then the first catering service won't cater to you. And you can't have more than 75 guests because there's a maximum of 75 guests being seated. Okay? All right, number 6. The graph of y equals f of x is shown. Graph y equals negative f of x minus 1. We want to be a little bit careful. Remember that there is an order to how we apply transformations. We usually want to start from the inside out. Now, nothing is happening inside of the function. Okay, nothing's happening on the inside. No horizontal shifts, no horizontal stretches or shrinks. So the first thing we're going to apply is the reflection across the x-axis. So I'm taking these points. So for example, I took this point, reflected it across the x-axis, and then I shifted it down 1. So that gives me this point. And then I just look for more points to do that. Here's another point right here. Reflected across the x-axis. Well, it's already on the x-axis, so you can't reflect it across it. And then you shift it down 1. Here's this point right here. Reflected across the x-axis. Shift it down 1. We get this point. Same deal here. Take a point like this one. Reflect it across the x-axis. Then shift it down 1. We get this point. So as long as you're doing the reflection over the x-axis and then do your vertical shift last, should be fine. Should get a graph that looks just like that. All right. Part B, graph y equals 0.5 times f of x. So we're multiplying a constant to a function. That's a vertical stretch or shrink. If the number you're multiplying by is between 0 and 1, it's going to be a vertical shrink. So 0.5, that's the same thing as 1/2. So this is representing a vertical shrink by a factor of 1/2. All that really means is on our original graph, we look at the y values and we multiply our y values, our function values, by 1/2. So here, this point has a y value of 3. If you do 3 times 1/2, you get 1.5. So the new y value, when x is -2, is going to be 1.5. Here, at -1, we have a y value of 0. 0 times 1/2, still 0. Right here, we have a y value at -1. -1 times 1/2 is -1/2. So our new y value is at -1/2. And you continue that until you go through the whole graph. All right. Number 7. Let g of x be this piecewise function. So we have a cubic right here. We got a linear function. We got a square root function. And here's our domain restrictions. Part A, evaluate g of -9 and g of 3. So when we're evaluating g of negative 9, first we have to look at the input. We have to figure out which domain restriction does negative 9 belong to. Well, negative 9 is going to be in between negative 20 and negative 1. So we are using this as our function. So we take a negative 9, we plug it in for x. So we have negative 9 cubed, just like this. Deal with the parentheses and the exponents first. Negative 9 cubed is negative 729. Then we multiply by this negative 1 on the outside. Negative 1 times negative 729, positive 729. For g of 3, here's where you have to be a little bit careful sometimes. We see a 3 here, we see a 3 here. This one is less than or equal to 3. So because of the or equal to sign, we must use this function because 3 actually belongs to this interval. So we use 4x minus 5, we just plug in 3 for x. 4 times 3 minus 5, that's 12 minus 5, that'll give us 7. So g of 3 equals 7. All right, part B. The graph of g has a closed circle. This is important. At negative 1 comma something. We want to find out what that something is. Okay, find the value of a. Closed circle. So when you think closed circle, you think less than or equal to, or greater than or equal to, something with an or equal to. An open circle would be with a less than or a greater than. So notice it specifically says the x value is negative 1, and we're looking for a closed circle. So I see two negative 1s for x values. Closed circle means I want the one that has the or equal to sign. So that means I'm using this equation, using this interval, using this equation. All right, so plug in negative 1, the x value, into that equation. I get negative 9. So that means I'm going to have a closed circle at the coordinate negative 1, negative 9. So a equals negative 9. C, on which interval or intervals of the domain is g increasing? Okay, so let's think about each of these different functions. So a cubic function does that. However, this is a cubic function that's been reflected across the x-axis. So instead of doing this, it's going to do this. So a negative cubic is always decreasing. All right. So negative x cubed is decreasing on really everywhere. So yeah, this thing's always going to be decreasing. 4x minus 5 is never decreasing. This is a linear function with a positive slope. This thing's always increasing. And square root of x plus 4 is also never decreasing. If you think about a square root function, going like that, all this thing is doing is move up 4, but it's still always increasing. All right, so this thing here, really this should say negative infinity to infinity. Negative x cubed is, it's always decreasing. However, negative x cubed is only defined from negative 20 to 1. So our function g, because negative x cubed is only defined on this specific interval, even though it's always decreasing, let me go ahead and fix this typo. Even though it's always decreasing, we're only defined, this is only applicable on this domain right here. So the function g is decreasing from negative 20 to negative 1. All right, number 8. Which of the following equations could represent the graph shown? Select all that apply. Okay, so you can tell from all the answer choices, and you can tell just from the shape of the graph, the parent function is y equals x cubed. It's the cubic parent function. So we want to know which of the following transformations could give us this graph. And some of them, as you can see, there's multiple that work. So negative x cubed minus 1. This would be a reflection over the x-axis and then a shift down 1. So if I took the parent function, reflected it over the x-axis, and then moved it down 1, I'd get a graph that looks like this. So that's obviously wrong. Number 2 is a reflection over the y-axis. So this graph, if we flipped it over the y-axis, look like that. Then you shift it down one, we get that. So both of these actually give you the same shaped graph. So these are both wrong. Part 3, take your cubic, shift it up one. Yep. That works. And then the fourth option, reflect it across the y-axis, then reflect it across the x-axis, then shift it up one. So let's try that. Reflect it across the y-axis, then reflect it across the x-axis, then shift it up one. Yep, that works. So 4 also works. All right, number 9. List and sketch each of the 6 parent functions we've learned so far. So here is a sketch of each one. On the main ideas document, I also included the domain and ranges of each of the 6 parent functions. So make sure you're aware of those as well. All right, final question. The graph of function f is shown below. The function f was created by transforming one of the 6 parent functions. Okay, so we got those right there. What is the parent function? Write a possible equation for function f. All right, so this thing is pretty clearly a square root function, okay? We see the shape right here. It's doing that. Okay, so we got a square root function because it just kind of stops right here. So we got a square root function, okay? Now, as far as transformations, here's the transformation that ended up working. So what I see when I look at this parent function, I see that it's been reflected across the x-axis. Okay, we can see the upside down shape to it, okay? But I can also see that it was moved to the left a little bit. Specifically, moved left 3, okay? So I got a square root, plus 3 under the square root is going to move it to the left 3. The negative is going to shift it upside down. And then when you shift it upside down, so let's say we shifted it left 3, like this. Then we moved it upside down, like that. It'd still be on the x-axis. This is not on the x-axis. This is up here at 1. So it's also shifted up 1, okay? Now, there was some kind of vertical stretch, and the vertical stretch turns out to be 3. You can play around with the vertical stretch in Desmos or your TI, but you'll find out that the vertical stretch was 3. But the important thing here is that it was shifted left 3, it was reflected across the x-axis, it was shifted up 1 after those things happened. Okay, so that's going to be the quiz review key. Very good quiz review, I think. Please make sure that you play back parts of this video if you're still confused about any of the problems. Please also take a moment to read through the Unit 3 main ideas. Put a lot of good stuff in here, a lot of things that you need to know. One of the things I definitely pay attention to on the second page, you want to be careful. Careful sometimes when you're looking at functions like this. If I have some stuff happening inside the function, like for example, if my function here was f of 2x minus 1 plus 4, this 2 would need to be factored out. So that, you factor a 2 out of a negative 1, you're going to get negative a half. You can check that again, by the way, by remultiplying back. You'll get 2x minus 1. But you would want it written like this so that you can see what transformations actually happen. So you can see that you have a horizontal shrink by a factor of a half, and that you have a horizontal shift right a half. Okay, so just go through this main ideas, these few pages, take some time to go through them, take some time to replay parts of this video if you need to as you're going through the quiz review. But best of luck prepping for this quiz, and I will see you soon.